is 2.3, right?
Yes. So let's say you were asked to find the limit of x squared plus 4 over x minus 2 when x approaches 2. Notice this function is undefined when x equals to 2. When x equals to 2, there's no value to it because you'll be dividing by 0. How can I find the limit? Well, you can graph it if you have a graphing calculator, but I'm trying to avoid the graph. So one way of doing it is really by making a table. You look at it from the left side and you look at it from the right side. So let's look at it. Here we go. Here's my table. I'll make the table big. I'll do the left and right at the same time. I'll calculate a few values for it and base on that. And that's really not my favorite method of doing it. But when everything fails, this method always works. Always. So I'm going to pick values for x here and find f of x. And pick values for x again and find f of x. I'm going to use this side for the left side. This is for the right side. So this is as x approaches 2 from the left side. And I want to find what is the value of that. And for this side, I'm going to use as x approaches 2 from the right side. And maybe if I'm lucky, I'll see I'm approaching a number. And I go, I see where they're going. So this one, you are approaching the 2 from the left side. This method is called find the limit using the table. And usually that's really my last resort for these problems. I don't want to do them this way. But with the graphing calculator, it's not that bad. How do you approach the 2 from the left side? What would you use for number? You're not at 2 yet. You're getting close to 2. Should I use 1.9? Is that close to 2? Let me try even closer. Let me try closer. And let me try closer. And see if I can see where the y value is going to. So here's the good news. I'm going to actually cheat here and use my TI-83, which is the lowest cheapest graphing calculator almost. You can get these on Amazon for about 20 bucks, 30 bucks. I'm going to write the function y equals parentheses x squared plus 4 close parentheses divided by parentheses x minus 2. I'm going to graph that. But I'm not going to graph it. I want to pretend I'm going to graph it. And if you remember, I said if you go to table set, you want to set your calculator to accept any number. So let's make sure, hit enter to accept this function. Table set, second that. And I want to be in the ask mode for the independent variable. This way I can use any number I want to use. So I want the independent variable, which is x, to be in the ask mode. If it's not in the ask mode, the calculator is going to do 1, 2, 3, 4, 5. It's not going to do 1.9, 1.99, 1.999. Once you get that in that mode, you can move it. Notice I can move it left and right, go down here, till you get that into that mode. You go, I want to be in the ask, and you hit enter. Then you're in the ask mode. Then you go second table to go to your table. You can use any number you want to. Let's put the 1.9. For 1.9, I got what? Negative 76.1. 1.99. Negative 796. 1.999. negative 7996, 1.9999, negative 79996. You can see where that number is going to. What do you think that number is going toward? Negative infinity. So my limit as x approaches the 2 from the left side is equal to negative infinity. Let's try the 2 from the right side. So you more than 2. You come into it from the right side. We'll try 2.1. Then let's get closer to 2 than 2.1. 2.01. Let's get closer. 2.001. 2.0001. And see what we have for an answer. 2.1. 2.1, I got 84.1. Is that what you got? 2.01. 804.01. 2.001. The calculator said roughly 8004. It's not even giving me decimals. But that's fine. 2.0001. 80004. Where's that number going toward? Plus infinity. So what's the limit of f of x as x approaches 2 from the plus side? That's equal to what? Plus infinity. This will work every single time. Do I really want to do it this way? No, because sometimes that number is a decimal number and it's hard to tell where that number is going toward. Is it 1/3? Is it the square root of 5? So maybe this is not the best way, but if everything else fails, when I say everything else, we didn't show you the other techniques, but if everything else fails, you can always go to this method. So when I go, what's the limit as x approaches 2 for this question now? I have to write what? Does not exist. Why? The left side doesn't match the right side. Let me try another one that we're probably not familiar with. This is actually one of those special cases. We'll get to it. What's the limit of sine of x over x as x approaches 0? Now again, I can make a table. When x is 0, if you plug in the 0 directly, you got a problem. You're dividing by 0. You know you can't divide by 0. I'll try a few values here, maybe 3, 4 values, and see if I can see a result, a pattern. 1, 2, 3, 4. I look at the left side. Now look at the right side. Here's the left side. Here's the right side. So this is the left side as x approaches the 0 from the left. What is sine of x over x will equal to? And you're approaching 0 from the left side. That would be what? Negative 0.1, negative 0.01, negative 0.001, negative 0.0001. Again, I'll go to my calculator here. Get out of this, quit. And let's go to the function, clear what's there, and let's write sine of x, close the parentheses, divided by x. Sine of x over x. Hit enter to accept that, and now it's in. Now let's go to table. Once you set the table once, it's set for the rest of your life, unless you play with it. Let's try negative 0.1. And negative 0.1 gave me what? 0.01745? Negative 0.01. Negative, what we got there? Point. Well, the other ones I didn't do. This is the 1.99, all that, and these are the old ones. You can clear them. I don't know how to clear the whole table. I can do one at a time. So this one is 0.01745. Let me try negative. Oh, I know why. I know there's a problem here. Guess what the problem is? These better be in radian, not in degrees. Let's go to mode. Where's mode? Radian. Anytime you're in trig, you want to be in radian. Unless you're taking a physics course, then you want to be in degree. They don't deal with radian. But in trig and math, it's always in radian. So let's go back and recheck these numbers. And notice the machine pulls the old numbers for x value. I don't want the old numbers. As I said, I really don't know how to clear the table. Maybe there's a button here. Is there a way to clear it? Yeah, delete. Where's delete? Oh, this one? Clear, escape.
Right next to mode.
Let's do table. Let's do delete. Delete, 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 delete. I mean, it doesn't really make any difference, just it gets in the way. So that's good. Has to be a button, delete all, but we'll take it. Negative 0.1. We got what? 0.99833. Negative 0.01. 0.99998. Negative 0.001. It says 1. Negative 0.0001. 1. So you can see this function is approaching what? The 1. So the limit of sine of x over x as x approaches 0 from the left side is a 1. Let's delete them again, so we'll have a clear screen. Let's look at it from the right side. A right side like what? 0.1, 0.01, 001, 0001. 0.1. 0.99833. 0.01. 0.99998. 1 and 1. It's going toward the 1. So what's my limit as x approaches the 0 from the right side? That's equal to 1. Are these numbers equal to each other? Yes, so what's my limit of sine of x over x as x approaches 0? 1. That's actually a special case, one of those identities. When we get later in the course, you'll see that. The limit of sine of x over x as x approaches 0 is always a 1. But that's the proof for it. As I said, this is really my last resort. I don't like to use the table. I got to plug in all these numbers. I got to remember I'm in degree mode, radian mode, switch this. So what can I do then? Let me take another one. We'll do it the long way, and I'll do it the shortcut. Six x plus 3, just a different one. I don't need a calculator. Well, I need a calculator for it. We'll look at it from the left side, the right side, then I'll do the shortcut. I'll do 3 values instead of 4. I'm trying to do the table to prove that the answer is really what the other method is telling me. So this is x approaches 2 from the left side of 6x plus 3. This is x approaches 2 from the right side, 6x plus 3. Okay, let's go back and type this function in. 6x plus 3. And go to table. 2 from the left side. I don't know why I picked 2 again, but it seems like I like 2 today. 1.9, 1.99, and I'll do 1.9999, 4 nines. I'm skipping 1. 1.9, I got 14.4. 1.99, 14.94. And if I do 1.9999, 14.999, do you see where that number is going toward? 15. So the limit as x approaches 2 of 6x plus 3 from the left side, this one says 15. Let's look at it from the right side. We'll start with 2.01, 2.001, and 2.0001. Clear all these values. Here we go. Let's try 2.01. 15.06. 2.001. 15.006. 2.0001. 15.0001. We'll have an extra 0 there. But what do you see that number going toward? 15 again, too. So my limit from the right is equal to 15. Now again, with graphing calculator, it doesn't seem that bad. But I still don't want to do it that way. As I said, this is my last resort. I'll use the table when I can't come up with any other way of doing it. So the same question now. I'll ask the same question. I'll try a different method and see if you like it better. Find the limit of 6x plus 3 as x approaches 2. My first method always, try direct substitution. That's my first step. Try direct substitution. Plug the 2 in. If you plug the 2 in, what are you going to have? 6 times 2 plus 3, which is what? If you come up with a number, that's your answer. Notice that's the answer. So which way would you rather do it? This way or that way? Yeah, but sometimes direct substitution doesn't work. But if it does work, if it gives you an answer, try that. So you're going to see me, I'm going to try direct substitution every single time. If I end up in trouble there, then I'll think of something else. Let me try another one. Yes?
Does it have to be a whole number? Or?
Nope, could be any number. So I'll try one with decimal. Find the limit. 6x squared minus 3 divided by x plus 2 as x approaches 1.4. Try direct substitution first. 6 times 1.4 squared minus 3 over 1.4 plus 2. If that gives you a number, that's your answer. You can try the table, we'll give you the same answer. 6 times 1.4 squared minus the 3. The top is 8.76. The bottom is what? 3.4. Divide them. And the value of 2.576470588. The reason we give you whole numbers with these problems, because we want the answer to be a whole number so you can type it in. But if they give you a problem like this, they might say around your answer nearest hundredth or nearest thousandth. They're not going to make you write all the digits. They say nearest hundredth, that would be 2.58, you know. But it doesn't have to be a whole number. So try direct substitution first. As I said, direct substitution does not work all the time. Let's try that. If you try direct substitution first, you're going to have what? 0 over 0. I don't care about the top there, but anytime you have 0 on the bottom, that's always a problem. Undefined. So you can do direct substitution. You can go to the table if you want to, or you can try to simplify that. Notice if I factor that, you can factor that as x minus 2 times what? X plus 2 over x minus 2. And these two will cancel each other out. Now try direct substitution. What are you going to have? 4. So if direct substitution fails, see if you can simplify the problem first, then try direct substitution again. If you try everything and nothing's working out, because sometimes you have a problem, nothing really is working out, you have to go to the table. Like this one. The limit as x approaches 0 of 1 over x. There is nothing I can do to simplify that problem. Nothing. So I'll go to the table, or I will graph it. If I go and graph it on my calculator, it will look like this. It will look like this. or I'll do it to the table, either way. Well, if you see the picture of it, you can look at the limit from the left and the right to see what the answer. What's the limit of 1 over x as x approaches 0 from the left? Yes, negative infinity. Notice as you approach x from the left side, right there, that's your y value, down negative infinity. And as you approach it from the right side, what's your value? What's the limit as x approaches 0 from the plus side? That's a positive infinity. So what is the limit as x approaches 0? Does not exist. Because they don't match. But this problem, there's nothing I could have done. Substitution, simplify, I couldn't. So I have to go either the table or the graph. I chose to go with the graph because I realized I didn't have enough space here to finish it, so I went with the graph. And I know the graph of it, so I said, I'll go with that. But if I had more room, I probably went with the table and see what the answer might be. Now, let's try this one. What's the limit? Square root of x minus 9 over I'm just making something up. I have no idea if it's going to work or not. 3, not from minus side. 3 from either side, plus or minus. I don't mean... What did I mean to write here? Wait. Let me reverse that. Let's do this. I'm not sure actually what I'm trying to do here. I'll do this. As x approaches 9. I have no idea where I'm going with this, but we'll see if it works out. I'm just trying to do something in my head quickly and see if it's going to work out.
Will you ever have a y instead of an x?
You could do anything. Could be any letter there.
Doesn't matter.
Yep. Any letter you can use there. Again, first step is what? Direct substitution. If you do direct substitution, what do you have? 0 on the top, right? The fact gets 0 on the bottom, oh, not good. And I don't want to go to the table, again, unless I have to. Is there a way I can simplify this? How can I simplify that? By what? Oh. By what?
That whole thing.
This whole thing?
Yeah.
Well, that's not going to get rid of it. You said multiply the top and the bottom by the whole thing.
Yeah. Damn, I was trying to.
Ah. I heard someone say conjugate. The conjugate is going to switch the sign then. If this is a minus, you make them a plus. If this is a plus, you make them a minus. You will see why in a second we switch the sign as I multiply this through. So notice I'm multiplying by 1. It's a fraction. If you multiply the top and the bottom by the same thing, it's not going to change the fraction. But let's simplify that. The top, when you multiply them, is going to be x minus 9. I'll leave it the way it is. Always tend to work out nicely. The bottom. What's the square root of x times the square root of x? I'm using the FOIL method. X. What's the square root of x times the 3? Positive 3, the square root of x. What's negative 3 times the square root of x? And what's negative 3 times the 3? So the reason I switched the sign, as I said, you'll see in a minute, so these pieces will cancel each other out. And what do you have left there? X minus 9 times square root of x plus 3 over what? X minus 9. And what do you know? These two will cancel each other out. So you end up with the limit of the square root of x plus 3 as x approaches 9. Now try direct substitution. It's the square root of 9 plus the 3, which is what? 6. I guarantee you, if we type that function, we start to approach 9 from the left and right, you will see that function goes to 6. Here's my calc. I'll wait till you finish writing, and I'll just do it on the calculator quickly. I'll look at it from the left side, I'll look at it from the right side, and see if it's going toward the 6. While you're doing that, I'll type the equation. So parentheses x minus 9, close parentheses, divided by parentheses the square root of x, close parentheses, minus 3, close parentheses. Notice I typed that problem there on my calculator. Now let me go to the table. Let's look at the 9 from the left side. You're not at 9, 8.9. 8.99. 8.999. 8.9999. What do you see that number is going toward? Can you see it? 6, right? Can you see the 6 there? Let's look at the negative numbers. Let me delete all of these and look at it from the left. So from the right. 9.1. 9.01. 9.001. 9.0001. And you see where that number is going toward? 6 again. So by looking at it from the left, from the right, both values approaching 6, and that's what this one tells me. There is a limit, and the limit will be approaching the 6. Now there's a few properties about the limits. I always take them for granted there, So I'll list the properties of the limits, but that's the process we're going to use for finding the limits. We'll try direct substitution. If direct substitution does not work, we'll see if we can simplify the problem, use conjugate, whatever we have to do, find the answer. If that doesn't work out, then let's go to the table. So let's try another problem. The limit x squared plus x minus 6 over x plus 3 as x approaches negative 3. Again, the first step is direct substitution. Let's try direct substitution. 9 minus, that's 0 over 0. 0 on the bottom is a problem. I always say that. Can I simplify that?
Yeah.
I can factor the top, right? That would be what? X plus 3, x minus 2. And when you factor that, these two will cancel each other out. This becomes the limit as x approaches negative 3 of x minus 2. Now try direct substitution. Negative 3 minus 2, which is what? Negative 5. Done. No table, nothing.
So how would you write that there? Would you still write it with the original function?
Yep, I'll just write this. I'll go the limit as x approaches negative 3 of x squared plus x minus 6 over x plus 3, that's an x here, is equal to negative 5.
Do you still write it with
Yep.
that, not the
Oh, yeah.
minus 2?
Nope. The limit, hope I have enough space here, as x approaches 0 of the square root of x plus 1 minus 1 over x. Again, the first step is what? Direct substitution. 0 over 0. Problem. When you have a square root, it's always the conjugate to clean it. That'll be the limit as x approaches 0 but now I'm going to multiply both the top and the bottom by what? The square root of x plus 1 plus 1. And if you FOIL the top, leave the bottom alone, because they tend to cancel nicely. I mean, you can multiply it out, but if you leave the bottom alone, you have x times the square root of x plus 1 plus 1. That's in the bottom. If you look at the top, what are you going to have? What is the square root of x plus 1 times the square root of x plus 1? X plus 1. The two middle pieces will cancel each other out, not even worth listing. One is plus the square root of x plus 1. The other one is minus the square root of x plus 1. And the last piece, what's minus 1 times plus 1? So I'm using the FOIL method, and I'm canceling in one step. What's plus 1 minus 1? Gone. So you end up with, and I'm going to simplify it even more, x over x times the square root of x plus 1 plus 1. Now the x's will cancel each other out. Limit x approaches 0, 1 over the square root of x plus 1 plus 1. Now try direct substitution. This So the answer is 1/2. So you write that, the question earlier, how do you write that? You write that the limit as x approaches 0 of the square root of x plus 1 minus 1 over x, the answer is equal to 1/2. There's a couple of special cases, 3 special limits for trig. You just gotta, we proven one a few minutes ago. We did one of them. Where was it? This one. The limit of sine of x over x as x approaches 0, that's a 1. We did the proof for that one. But there's 2 more, and I can actually prove them by making the table here. I'm just going to believe it's correct because they've been correct for about 1,000 plus years. So if nobody can find a mistake in them in a few thousand years, I'm sure it's still correct. So these are 3 special cases, 3 special limits. The first one, the limit of sine of x over x as x approaches 0, that's equal to 1. The second one, the limit as x approaches 0 of 1 minus cosine of x over x, that's a 0. And the third one, the limit as x approaches 0 of 1 plus x to the power of 1 over x, that's equal to e. Somebody came up with these, and they've been working for a lot of years. Where people get in trouble there, they see a problem like this. What's the limit of sine of x over, or sine of, not x, I'm sorry, sine of 5x, I'll use 5, over x as x approaches 0. I'll go, that's 1. I go, nope, try again. You want this one and this to be exactly the same. If these two are not the same, the answer is not 1. So how can I make these two the same? This is 5x, but that's x. Multiply the top and the bottom of this fraction by 5. If you multiply by 5, what are you going to have? You'll have the limit of 5 times sine of 5x over 5x as x approaches 0. Now I said there's a lot of properties of the limits, and I didn't really go through them. I was about to go through them in a few minutes. But one of them says if you have a constant like the 5, you can pull that constant to the front. So I can take, this is one of the properties of the limits. If you have the limits of a constant times anything, you can move that constant, put it in the front. It doesn't change your answer. So if I do that, this will be what? 5 times the limit as x approaches 0 of sine of 5x over 5x. That doesn't look like this. This one says x over x, not 5x. I want to prove actually that's going to be a 1. As long as these guys are matching, the answer is 1. I can do a change of variable. If I let u equals 5x, then I can take this problem now and rewrite that, here we go, 5 times the limit. And by the way, when x is 0, what is 5 times 0? 0. So that becomes u approaching 0. This will be what? Sine u over u. That fits this one. We're just using u versus x. Who cares what letter we use? So the answer to this is a 1. That's 5 times the 1. The answer is 5. So as long as these guys are matching, the answer to this is always a 1. I just wanted to show you the math, the reasoning behind it. I just did a change of variable. That's all I did. So you'll see some of these problems that try to sneak them in. They put 5x on the top, they put 1x on the bottom. Or they'll put 5x on the top, 9x on the bottom. Because, uh-oh, what do I do now? So you'll see a problem like this. Limit of sine 6x over 7x as x approaches 0. I go, darn it, I don't like that 7 there in the bottom. Well, I can write that the limit x approaches 0. Write this 1/7 times sine of 6x over what? X. But I don't want that to be x here. I want that to be what? 6x. So I got to multiply the top by 6 and the bottom by 6. And I can rewrite that, the limit, as x approaches 0. What is 1/7 times 6? 6/7 sine of 6x over 6x. As I finished saying, if you have a number in the front or inside the limit, you can take it outside the limit. That's a constant. That'll be what? 6 over 7, the limit as x approaches 0 of sine 6x over 6x. As long as these guys are matching, the answer to this is a 1. That's 6 over 7 times 1. Your answer is 6 over 7. So that's the type of trick they do with that identity. They don't just give it to you straightforward. I said there's a lot of properties about the limits. This is one of them if you have a number. So if you want to list the properties of the limits, you can say if you have the limit as x approaches c. If you have a constant, we can use k for constant. We're not going to use c because we make an x approaching c. But if you have a constant times a function, you can actually take that constant to the front. So if you have a constant, you can take it to the front. You can leave it, or so when you're given a problem like this, what's the limit of 3x squared as x approaches 2? You can do that as one problem if you want, or you can take the 3 to the front. You can leave it like this or pull the 3 in the front. Your answer is not going to change. So if you deal with that as one problem, what's 2 squared? 4. 4 times 3, which is what? 12. If you do it as two separate problems, that's 3 times. What's the answer to this? 4. What's 3 times 4? 12. So you can leave it as one problem, or you can take the constant to the front and leave that one. In this case, I really want to pull the constant there so I'm not confused. That's one of the properties of limits. Another property of a limit, it says the limit of a constant is the constant. Limit of k as x approaches any number is equal to k. Common sense. What's the limit of 5 as x approaches 0? We say when you're doing limit, the first step is direct substitution. Replace x with 0. There is no x there. The numbers don't change. The 5 is the same today, tomorrow, next week, next month. So it says if you have x, take it out, put a 0. I don't have an x, so it's still a 5. So that's another property. The limit of a constant is the constant. Another one, I just didn't even pay attention to it. If you have a limit of 6x squared plus 3x as x approaches 0. This one says when you have additions, subtractions, it's up to you. You can leave it as one problem or you can break it down as two problems. So that's really the limit as x approaches c of f of x plus or minus. It doesn't matter if you have addition or subtractions. You can break it down to the limit of the first one. And if it's addition, you leave it addition. If it's subtraction, you subtract the limit of the second one. That's another one. It says when you have additions, subtractions, if you wish, if you want to, you can break it down to the limit of that. Break it down to two problems. And now you go, okay, when x is 0, what's 0 squared? 0 times 6, that's a 0. What's the answer to this? 0. What's 0 plus 0? 0. If you do it as one problem, the answer is also 0. Doesn't change. Where this method might be helpful, I'll show you where the breakdown. I'll make one up. I just thought of one off the top of my head. This just came to me. I don't know where it came from, which planet, but a problem just 5x squared plus 6x times okay, the sine of x. That wasn't for addition actually, for multiplication. I didn't mean to do that. Okay, let's do this. I'll come back to this one. I like that problem I was thinking about, but I'll come back to it. I'll put a number here. 6 sine of x over x. I had a different problem in mind. I'll come back to it. So notice with this one, I might want to break it down to two problems. The first one is the limit as x approaches 0 of 5x squared over x plus, because I can write, let me write it like this first, 6 sine of x over x. I can write it like this. Because if you try direct substitution, you got a problem. With direct substitution, you get 0 on the bottom. I don't care what the top is. So you can't solve it. It seems like I can't do it. But if you break it down like this now, what will happen? This becomes the limit as x approaches 0 of 5x. X squared over x becomes 5x plus the limit as x approaches 0 of 6 sine of x over x. We know we can take that 6 and put it in the front here. Now let's try and solve it. Direct substitution here. That's 5 times 0, that's 0. This is a special case. We know the answer to this. You can't do direct substitution. That's a special case. That's a 1. 6 times 1, 6. So 0 plus 6, the answer is what? 6. So that's a place maybe where you want to break it down. Again, if you have subtraction, you can break it down to subtractions. The special cases I mentioned actually are right here in our book, if you have the book. Those are the 3 special cases. Every calc book has these in it. I think I have a marker here, highlighter. I can highlight them in case you can't see them. Pink highlighter. But those are the special cases. The limit as x approaches 0 of sine x over x is 1. The limit as x approaches 0 of 1 minus cosine of x over x equals 0. And the limit of 1 plus x to the power of 1 over x as x approaches 0. That's an E. This one you see probably, out of the 3 of them, this you probably see 80% of the time. This one you might see about 9% of the time. And this one you might see 1% of the time. Probably even less. But this one you see a lot. Very popular one. Okay. That's the end of section 2.3. Here's the good news. We only have 2 more sections to finish the chapter. So next Monday, guess what? Chapter 2 is done. Then we'll start to crawl. So let me stop.